All right, guys, for today, our very last section is usually the thing that scares students the most. It is word problems. I know. A lot of people, guys, a lot of you, stop. Thank you. All right, so guys, we are going to kind of break these apart. We're going to kind of find those keywords so that we can write the equations. So the point of today is to not only solve them, but to write an equation. Okay, that is a lot of times what people struggle with the most, is being able to write the equation, and then also I'll ask a second question where I'm going to ask you to solve it for something. All right, so first let's just kind of go through our keywords. All right, so good. Equals, is, are, typically that is what you see for the equal sign. Okay, so if you see that word is or are, that's where you would want to put the equals. Is less than and fewer than. What did you say? That is a minus, or I'm sorry, less than or fewer than. It could be, I know what you're going with. It could be the minus sign, or if we're talking about inequality, that would be your less than symbol. Okay. Is greater than or more than. That's your greater than symbol. Do you notice instead of an equal sign, because you see the word is, it's got the is less than. Instead of an equals, is greater than. That would be how you would know it's not a plus or a minus, which is initially what he was wanting to say, the plus or the minus. Bless you. Okay, so no more than or at most. Because that one, no more than, would have to be a less than or equal to. It's no more than. Like if I say you could bring no more than 5 friends with you, you could bring 5 or less. Okay, so that's a less than or equal to. No less than, or at least, is greater than or equal to. Correct. Multiply, times, at, of, per, each, product. It's what? Yes. Dot, multiply, little asterisk, depending on what symbol you want to use. That's multiply. But yeah, notice how many words can be used to like symbolize that multiply. There's a lot of different words. Divide or quotient. That should be an easy one. That's a division. Plus, sum, total, more than, together, combined. That's adding. Minus, difference, less than, fewer. Subtract. Now, don't flip the page, because we need to talk about something very important that shows up here. On this plus and minus, you have the less than and more than words. Okay? Very important is the order in which things go. Now, if I add 4 plus 2 or 2 plus 4, does it matter? No, it doesn't. But 4 minus 2 or 2 minus 4 makes a big difference. Okay? And this is like one of the key things I need you guys to make note of. If you see the word less than, anytime that than shows up with less than, that means like the order that you're reading it, it's actually flipped. So like if I said I want 3 less than x. Well, I know less than means minus, but it's x minus 3. Do you see the flip going on? It's not 3 minus x. That than right there makes me flip them to x minus 3. That's the only one that really like seems to trip people up, is right there. So if it's less than, the than flips them. Otherwise, the order I read it is the order I'm writing it. Okay, don't make this harder than it has to be. Okay, so just make a note of that than on the less than. If you flip it on the adding one, it doesn't really matter, so I'm not really concerned about that one. A little bit of vocab for you guys. Just again, if you're taking air test again, or if you're going to take that ACT, the SAT, they like to throw those random words at you, but you probably know what they are, but like because they used a word that you're not sure. The variable that is changed in an equation or a scientific experiment, the thing that keeps changing, that affects what you're doing, that is called your independent variable. It's independent of everything else. It doesn't matter, right? The amount of calories I consume in a day depends upon how many cookies I eat. So is the calories or the cookies the independent variable? It doesn't care about the other one. The cookies, right? Every time I eat more cookies, my calories are going up. So what does that make the calories? Larger, yes. That is your dependent variable. The calories depend on how many cookies I'm eating. So it is dependent upon whatever else the other thing is going on. Okay? So independent variable doesn't care about the other one. The dependent variable, its value changes every time I change something else. Okay? So you're okay on variables or the terms. Those show up a lot on air test, ACT, SAT, they show up a lot. All right, so for example, you're going to a basketball game. You purchase a ticket for $25. Each soft drink you purchase is $3.25. Write a linear model. Linear model could be an equation, an inequality, like you have to determine which one it should be. For the total amount you spend, Y, after purchasing the ticket and each drink, X. So this is the type of thing you're going to be given today, and you are going to have to be able to write the equation. Now this one's given to you. Now the important thing we recognize is what variables, they actually tell me to use an X and a Y. You would have to then use an X and a Y. Personally, if it's me and I'm looking through, I'm writing equations, I rarely use an X and a Y if they don't tell me to. Because for me, I would use probably C for cost, and I would use like a D for drink. That way I know what that variable stands for. To me, that makes more sense. But if it says use X and Y, I have to use X and Y. Okay? So if I look at my equation, take a look. It says I'm going to a basketball game. I purchase a ticket for $25. Why is there no variable attached to the $25? Good. That's not changing, right? I'm going to the game. I bought a $25 ticket. It's just 25 bucks. That's it. Right? So I'm $25 plus, because I'm adding on to my total cost, right? I'm spent the 25. What's 3.25x stand for? The drinks. It's 3.25 for every drink. Well, if I didn't tell you how many drinks I was having, so it's 3.25 times however many drinks I'm going to buy. Okay? And then those two things added together would give me Y, which is the total amount I spent. Okay? So in this equation, which is dependent and which is independent? So which one is dependent? It depends upon the other one. It's either X or Y. Y is this is my cost, and then this is my drinks. Which one is dependent? My cost is dependent. So this is the dependent, because what does it depend on? Depends on how many pops I'm drinking, right? Pops, drinks, whatever, right? So this is independent. All right, we just need to get used to kind of seeing which one's which. Yeah, my cost depends upon how many drinks I buy. That's the way, like, in my mind, I always kind of think about which one depends on the other. Does the number of drinks I buy depend on my total cost? Well, no. Does the cost depend upon how many drinks I buy? Yes, it does. Okay, so if you kind of word it to yourself like that, which one depends on the other one, it makes it a little easier. All right, Josh is hauling bundles of lumber. The route he takes has a bridge with a weight limit. Josh uses the inequality shown to determine the number of bundles of lumber he can take across the bridge. So 4,600x plus 6,000 has to be less than or equal to 100,000. What does the 100,000 stand for? The weight, what? The weight limit. Good. That's got to be the weight limit of the bridge. And you will have questions like this on your test this week, where I just give you the equation, story problem, and I ask you, what do all these things stand for? What? You like these? Good. What does the 4,600x stand for? Mackenzie? Good. So that's going to stand for the weight of all the bundles. How much does each bundle weigh? Each bundle weighs 4,600 pounds. Good. What does the 6,000 stand for? It's the weight of the truck. Because does that change? No. The truck itself with nothing on it weighs 6,000 pounds. So like that is a constant. Notice there's no variable, meaning that's not changing. Okay, it's just 6,000 pounds no matter what. If I just drive my truck across, it's only 6,000 pounds. All right, is the variable x dependent or independent? What did x stand for? That's my bundles, the number of bundles I'm taking. Is the number of bundles dependent or independent? It is independent. What would be dependent? I don't have another variable up here, but what would be dependent? The 100,000 doesn't change. The total weight, thank you. The total weight of my truck with all my bundles on it, that's dependent. That's depending on how many bundles I'm taking. Okay, that depends upon it. All right. So why did we learn last week how to solve literal equations? Like rearranging them to like solve for W, solve for P. Why did we do that? Training, good. Right? Why do you go out and run miles to prepare for a marathon? Training, right? It gets you ready for it. We're lazy, that's why. All right? It's truly, this is why we do it, because I'm lazy. I will tell you guys that every day. I'm a lazy mathematician. If I can do it in less steps, I'm going to do it in less steps. So if I had to plug more than one number into an equation, why would I resolve that equation every single time? If we can just solve it once for a certain variable, I don't have to do as much work. All right, so number 2, a delivery person uses a service elevator to bring boxes of books to a customer. The formula below can be used to determine how much weight is on the elevator. Determine if it is safe to use the elevator for the following number of boxes of books. So again, they gave me the equation. What do you think the 2,000 stands for? The weight limit of the elevator. What's the 175? How much what weighs? The delivery person. And then the 50x, that's books times however many bundle or boxes I have, right? So I could plug this in, right, 25, and I can figure out what this is and see if it works. I can plug in the 32. I can figure out what that is, see if it works. Can I just solve this for x and then see what happens? Yeah. If I solve this for x, what do we have to do first? Minus the 175. So we get 50x is less than or equal 2,000 minus 175 at 1825. It's a Monday morning and I'm tired. Don't trust my math today, guys. All right, and then divide by 50. Do I need to flip the inequality? No, to not divide by a negative. And what do we get? 36.5. So x, which stood for how many boxes of books I have, has to be less than or equal to 36.5 boxes. So real quick, now I solved that problem once. Can I answer really quickly now which one works? A, does 25 boxes okay? Is 25 less than or equal to 36.5? Yeah. How about B? Yep. C? D? No. That's too much. It's going to put me over that weight limit of the elevator. Okay? So again, you could plug in every single one and solve them all. Or I can just solve it once and I'm calling myself good and I can just see the answer. Okay? Be lazy with me. Okay? Solve it once and then it's a lot faster. All right, now it's our turn to try to write these equations. All right? So Jared weighs 15 pounds less than twice Kate's weight. Write an equation for Jared's weight, y, in relation to Kate's weight, x. I'm not even reading that question. We are looking at number 3, the very first part, wants the equation. Guys, I'm going to tell you right now, the equation to me is more important right now than you actually solving the one question I asked. You have to be able to write an equation. So Jared weighs 15 pounds less than, what's less than mean? Minus, and since the word than is there, is the 15 going to be first or second? It's going to be second. Twice Kate's weight. What's twice mean? It's 2 times. So what's Kate's weight? What variable did it tell me to use? Kate's weight is X, so it's going to be 2X. And then that should equal Y. Jared's weight is Y. So double check before we move any further. I'll make sure we're okay on where this equation came from. Because again, I care more that you can write that equation than you can answer that question. Okay? All right, so again, Jared's weight was Y. So when it said Jared weighs 15 pounds less than, so minus 15, twice Kate's weight. 2 times X, and that's Kate. Are we okay? I kind of pulled the less than. It was a minus. That means the 15 has to go after that. Twice Kate, 2X. Again, if it did not tell me X and Y, I would have said 2K. 2 times Kate's. To me, that makes more sense. But it said X and Y, so I had to go with it. All right? So then it asked, how much does Jared weigh if Kate weighs 110 pounds? If you wrote the equation, all you have to do then is plug it in. Okay? Kate weighs 110. Kate was which variable, X or Y? She was X. So plug that in for X. So 2 times 110 minus 15. That's going to give me Y, or it's going to give me Jared's weight. So 2 times 110 is 220 minus 15, 205. So Y equals 205. Now, you guys, the key thing, hopefully you remember from like when you were younger grades, if it is a story problem, what should all of your answers have on them? A label. 205 pounds. Yeah, make sure if it's a story problem, you need a label. If you do not put a label, I'm going to take a point off. Okay? All right, that was our first story problem. You guys, I know we're not looking forward to that. Are we doing okay? We got this. Number 4. Jesse paid $2 more than 3 times the price that Woody paid for his cowboy boots. Write an equation to represent the amount Jessie, J, paid for her boots compared to what Woody, W, paid. So does it make sense with the variables this time? To me, it makes it easier if you use those type of variables as opposed to X and Y. They make more sense. All right, so again, when you're reading through, Jesse paid $2 more than, what's more than? That's a plus, good, plus 2. If you put the 2 in front, it's not wrong, but you are right. The than would make you flip it, because adding doesn't matter, but, so plus 2. $2 more than 3 times what Woody paid. So 3 times what? 3 times W. $2 more than 3 times what Woody paid. I think Jesse overpaid. What do you think? And that's going to be what Jesse pays, equals J. Yeah. Okay, can we finish, Rob? Do you not have glasses, contacts? You are squinting hardcore today. Okay. All right. If Jesse paid $212, how much did Woody pay? Now, guys, this is really, guys, be careful here. Don't always get in the habit of always just plugging it into the equation, because what did they give me? They gave me Jesse. This is where, for me, it makes more sense to use W and J as opposed to X and Y, because, like, if Jesse paid, okay, so Jesse's J. So Jesse, that goes in here, 212. So this is 3W plus 2 equals 212. Okay, so don't always think you're going to plug it into the equation part, because it doesn't always do that. So we just need to solve this. Subtract 2. So 3W equals 210. Divide by 3. And how much did Woody pay? Oops. $70. Maybe Jesse's just buying nicer boots. What do you think? So the boots look the same? They look a little different. She's like, mine are worth more. All right, number 5. You're attending a basketball game. Purchase a ticket for $25. Each soft drink you purchase is $4.75. Write a linear model for the amount of money you spend, Y, for the number of drinks you purchase, X. Okay, so I'm attending a basketball game, purchase a ticket for $25. So what is the first thing you're going to write in your equation? 25. That doesn't change, right? That's just my ticket, 25 bucks. And then each drink I purchase is $4.75. So it's going to be $4.75x. What's going on with my cost of my ticket and my drinks? I'm going to add them. And that's going to equal Y, which is my total amount of money I spent. All right, so then the question asked, if you purchase 4 soft drinks, how much total did you spend? Does the 4 go in for X or does the 4 go in for Y? That is X. That is 4 soft drinks. Soft drinks were X. So that's going to go right there. So 25 plus 4.75 times 4 equals Y. So how much money, you can just type that right in the calculator, how much did you spend? $44? I'm trusting you. Is he right? You're really thirsty. It's expensive. Any basketball game, baseball game, like that kind of stuff, their drinks are always super high. All right, number 6. You are planning a birthday party at a bounce house for kids. The cost for the party is $275 for 10 kids. Each additional child is $10. Write a linear model where C is the total cost and K is the number of additional kids. Again, they use C for cost, K for kids. Again, that makes it easier. So what do I have to write? What's my equation look like? What do I know is like a flat cost? Right away, it's going to be $275. Oops. So $275. Am I going to add on to that cost, subtract from that cost? I'm going to add on to that. How much am I adding on? $10 for every kid, and that should equal cost. C, cost. Don't look at the second part yet, guys. I want just an equation. You should have 2 variables in it, just the equation. All right, so it's $275 right away, and then I have to pay an additional $10 for every kid beyond those 10. If you invite 15 kids total, how much will the party cost? Read very carefully. Ooh, I'm hearing some different answers. What do I plug in for K? Yeah, that was a tricky one. I like this question. Yeah, it's $275 for 10 kids. I invited 15, so I have 5 extra kids. Yeah, so right here, this 15, I only have 5 extra. So 275 plus 10 times 5 equals the cost. So how much is it? That's $325. Hey, Victor, can you work on your review not while I'm teaching you the new stuff, please? All right, number 7. It takes the teacher 5 minutes to grade each test. Write a linear model for the amount of time it will take the teacher to grade all of her students' tests. This is why when you guys get mad that your teacher didn't have your test graded the very next day, it takes time. All right, so what's your equation look like? It takes 5 minutes to grade each test. 5 times X. Or I might even go 5 times T. And that equals, yeah, test and time both start with a T, don't they? So 5 times, how about Q? We'll call them quizzes. 5 times for every quiz equals T for my time. Yeah, either way. If the teacher has 24 students, how long will she spend grading the test? Where's the 24 go? To go in for Q or T? Q. 24 students means 24 quizzes, right? Or 24 tests. So 5 times 24 equals the time, which is how long? 120 minutes. You're right. So that would be 2 hours if you want to kind of think of it that way. Hi, Luke. So again, stop and think. I mean, truly, a test will take at least 5 minutes for me to grade each person's test. At least. No, for me to grade them, at least 5 minutes. If you get right answers. If you miss a lot of things, it's going to take me longer than that. Yes. No, I'm trying to get you to understand, like, I try my best to get them back to you the next day, but sometimes it doesn't happen. Well, yeah, if you get the answers all right, I can grade them a lot faster. So just get them right, would you please?
Just take my word for it that I get them all right.
No. All right, number 8. The cost of parking in a parking garage is a base fee of $4 plus $1.25 for each hour that you park. Write a linear equation that models the total cost, y, of parking in terms of the number of hours, x. So they want me to use x for hours. Good, so it's a base of $4. And it even said the word plus, right? 1.25 times x for every hour. And that should equal y, my total cost. So if you parked in the garage for 7 hours, what was your cost? Where does the 7 go? It goes in for x. So 4 plus 1.25 times 7 equals y. What is it? 1275? Oh, I love lazy mathematicians. I am one myself. Okay, how are we feeling so far with story problems? Are they not, maybe not as bad as you thought they were going to be? You just don't like them, yeah. It is taking simple math and putting it into a realistic, like, life set. That's not realistic? You guys are never going to park in a parking garage?
You're gonna need to judge how much money you spend to see if it fits in your budget.
Thank you. Victor, I am liking you more and more today. No, I didn't. No, I didn't. All right. Number 9. You are a hairdresser at a salon. Tell me this is not real life. You guys, there's a lot of cons people in this school.
That's budgeting.
All right. You pay $200 a day to rent a booth from the salon. You charge $35 for each haircut. Write a linear model for the amount of money y you will make each day with x number of haircuts. So we need to write the equation. Again, the equation is more important than the answer. Mackenzie? Good. So 200, because that's just what I'm paying. Now you said plus 35x equals y. I have a problem with that. Because what's the 200?
I would just do 200 minus.
So we got a lot of things going on, which I like. What is the 200? Let's talk about that. This is what I have to pay, right? That's what I have to pay in order to actually, yeah. What's the 35x? This is the amount of money I make. So if we're talking about how much money I'm making, what should I do with those numbers? Which one, am I adding them? No. I'm subtracting, right? Which one gets subtracted from which? So you want to do 200 minus 35x? Or you want to do 35x minus 200? It's 35x minus 200. No. Don't divide. All right. Let's talk about it. This is the amount of money, guys. This is the amount of money that we're making, right? So I make $35 for every haircut. So I just keep making $35. Every time I do a haircut, I make more money. But if I'm talking about like my profit, how much I actually make, I have to take whatever I make for the day. I got to pay $200 out of that to rent my booth. So why is that's how much money I actually bring home. If I wrote 200 minus this, what would happen if I did like, I don't know, 20 haircuts? 200 minus a number bigger than 200 is going to give me a negative number, which I don't want to do that. Okay? Now, if I did this way, let's say I only did one haircut that day. 35 minus 200, is that okay to be negative then? Yeah, because that means I lost money that day. Okay? But mathematically speaking, that it's okay to have a negative there. Yes. What is the minimum number of haircuts you need to do to make a profit each day? Now, is an equal sign the right sign to have in there? No, it needs to be an inequality, right? It needs to be a greater than. Now, this just said to write a model, right? So I didn't know. But when I read this question, I need that to be greater than or equal to. What would you put here? These are all things we need to stop and think about when we write these. For me to make a profit, I need to make what? More than what? I see what you're saying. This needs to be more than 200, right? But what about this minus 200? It needs to be more than, a profit is anything more than 0. Because this is already taken off that, 200 bucks. Yep. So do I want greater than or equal to? Greater than. Do you want it equal to 0? I don't think 0. Just greater than. All right. So if I would solve this, to make a profit, it would have to be 35x minus 200 has to be greater than 0. Now, some of you earlier were like, you need to make more than 200 bucks, right? What's the very first step in solving this? Adding 200. So what did you guys tell me? I need to make more than $200, right? Greater than 200. That's the very first thing you guys said to do. So that was right. This part of the equation needs to be more than 200. That way I'm making a profit. So that makes sense then. And then divide by 35. X is greater than, what's 200 divided by 35? 6? I don't know. I'm asking you guys. What is it? 5 and 5/7. So if I asked you, how many haircuts do I need to do? I need to do 6.
You do 5 and then you start one and we'll finish it and stop.
No, I can't. Because that says X has to be greater than that. So I need to do 6 haircuts to make any money. Right? If I don't actually, I'd make a profit of $10 that day. Get all those haircuts to make 10 bucks. But guys, honestly, that's a very realistic situation for a hairstylist. Because there's 2 different ways I know for sure, like the hairstylist that I see, she used to be at a place where she just made a base pay, like she didn't pay rent or anything, so she just made so much, or like she got a percentage of all of her sales for the day. But then she ended up switching where she pays a booth rental, like this one, and she actually makes more money. So it depends on how many clients you have and like how much you charge and if it's worth it for you or not. You could make a lot of money. Yeah, Toby.
Most of these nowadays are going to be like houses, so they usually aren't that expensive to rent the spot, but they take a certain percentage.
Yeah, and it depends. That's where, like, I know for my stylist, she said she made more to just pay like a higher booth rental and not give up any of her sales. Yeah, I think you're right. Massages do that too. Yeah, sure. Yes, we can. All right, Michael can spend no more than $15 at the gas station. If he's already buying a $3 energy drink, how many $2 bags of chips can he buy? Write an inequality for B bags of chips, then solve. All right. So, did you know it was an inequality before it said write an inequality? Good. You should recognize that by the way that's worded. No more than. Is no more than less than or equal or greater than or equal? You can't spend more than 15, so I can spend $15 or less. So that's going to be less than or equal to 15. What has to be less than or equal to 15? He's buying a $3 energy drink. So 3 plus 2B. Yeah, it said to use B for bags of chips. Right? He's already spending $3 on his drink plus $2 for every bag of chips. Needs to be less than or equal to 15. Okay, so it said to write an inequality. I did. And then it said to solve. So solving this, we'll subtract 3. 2B is less than or equal to 12. Divide by 2. Less than or equal to 6. So how many bags of chips can he buy? 6 or less. So he can buy 6 or less bags of chips. Right?
Which one's your 6 and which one's your 2?
That one's curved. That's Toy Story 4.
Okay, I haven't watched Toy Story 4 yet. I haven't. Is it sad?
It's good, but I hated the end.
I heard it was sad.
I hated the end. I agree. I don't want to give it away if people haven't seen it, but I hated the end. I mean, it was a good movie, though. I liked everything up to that point. All right, number 11. A puppy named Cricket was 4 pounds when he was born. If he gains 3 pounds per month, M, write an inequality that represents the weight W of Cricket.
4 times 3. Base of 4. Base of 4, then 3.
So 3 plus, no, not 3, 4 plus 3M. And I know there's a W for his weight. This one's always tough. When it wants the inequality, in my mind, like, it would be a equation by what it's given me, but it wants an inequality. So now I'm going to tell you guys one thing. For me, when I'm writing inequality, having the single variable on this end sometimes is confusing. I might put it on this end. So his weight, is that greater than or less than that? Well, you know what? Let's do it this way. Before I put it in here, let's read this and see what makes sense. How many months will Cricket weigh 64 pounds? So let's just kind of, let's leave it as like a gap for now, right? Let's just kind of leave this as my blank. I don't know which way it goes until let's solve this and see what makes the most sense. That's honestly the way I do a lot of these. When it wants that, I'm like, I don't know, it could kind of go either way. I could argue both sides. So let's just kind of leave it blank. So 64 pounds, where does that go? M or W? That's W. So 64, I don't know what the symbol is. 4 plus 3M. So if I'm solving, subtract 4. So 64, I don't know the symbol. Sorry, 60, I don't know the symbol. 3m. Divide by 3. M, I don't know. 20. So 20 is months. So the months have to be, do the months have to be greater than 20 or less than 20 for me to weigh the 64 pounds? It would have to be greater than or equal than 20. Right, do you see? Now I know that I just wrote a less than symbol. Do you see why I said that was greater than? I was reading it backwards.
Yeah.
The months have to be greater. That has to be the Pac-Man's eating the months because it's bigger. So this should have been that way. The inequality ones are rough. I agree with you. They get rough. Honestly, I think it makes more sense to, when it asks the question, solve it, see what makes sense, and then go back and put it back in. Okay? Because otherwise it gets a little confusing. Or put in a symbol, and then when you get to the end, be like, oh, that don't make sense, and then flip it. All right. Last one. Kelsey has already spent $20 on a pair of pants. If shirts cost $14.50 each, write an inequality for how many shirts S she can buy if she had D dollars at the start of her shopping trip. I know. Okay. But you recognize, right? Some of you kind of glaze over the word. It does say inequality. So we need to write that. It's the less than or greater than symbols. It's not an equal sign. So Kelsey has already spent $20. So we're going to start with the 20. Are we adding on to what she spent or subtracting from what she spent? We're adding on to what she spent. What is she spending? $14.50 for every shirt, so $14.50 S. And then dollars. This has to be greater than or equal to or less than or equal to the number of dollars. Less than or equal to. Do not spend more money than you have. Okay, so in this case, it made sense to leave it over there, right? The amount she's spending has to be less than or equal to how many dollars she actually has. Okay? If Kelsey had $100 at the start of her shopping trip, how many shirts she can buy? Where does the 100 go? That's D. That's how many dollars she has, right? So 20 plus 14.50 S less than or equal than 100. Good. Subtract the 20. Good. So we'll divide by the 14.50. So S has to be less than or equal to, what do we get? 80 divided by 14.50. 5.52. Okay, keeps on going. So the question then is, how many shirts can she buy? 5. It says shirts has to be less than or equal to this. Right, we're not buying half a shirt. It doesn't make sense. So she can buy 5 shirts or less. So guys, as you're working through story problems, the big thing, especially with inequalities, is you want to make sure you understand what you're solving for. I think so often in math, you guys are like, I know I do step 1, 2, 3, 4, answer. I'm like, what does your answer mean? I don't know. Like, math in and of itself, just to do problems, let's be honest, doesn't mean anything. And I know a lot of your math career, that's how it's spent. Just doing meaningless math that you don't understand what you're doing. This, to me, at least makes sense. Like I'm solving, I can buy 5 shirts or less, okay, in order to stay within how much money I have. If you guys next year as seniors, I would highly recommend that you would take the financial algebra class, which Kurt just took last semester, Harley just took last semester. That class is all real world math, where all the math you do actually makes sense as far as when am I going to need this in my life. Like it's good. You do get to figure that out. So, I mean, Kurt, Harley, would you guys recommend that class? As math actually is for a purpose? It's very real world math, which is what I like.